One of the ways that we've defined functions is just as lists of the sets of ordered pairs that are in the function. Here we have three functions defined as a list of ordered pairs. And notice in the first function, each element of the domain is unique. That's really a function. In the second, again, each element of the domain is unique. That's really a function. And in the third, each element of the domain is again unique. That's really a function. These three are all really functions. And remember, to evaluate a function given in this form, we're looking for the value of y associated with the given value of x. So if we want to take f plus g of 3, that's going to be f of 3 plus g of 3. F of 3, we'll look in the function f, find input 3, that gives us output 0. So f of 3 is 0. Looking in the function g, we find the input 3 gives us the output -7. So g of 3 is going to be -7. F plus g of 3 is 0 plus -7 is -7. What if we want to take h minus g of 1? Well, we'll take h of 1 minus g of 1. To take h of 1, we'll look in the function h. We'll see input 1 gives us output -8. But then when we try to take g of 1, we see that there is no pair in g with which has input 1. So when we try to take g of 1, we can't do it. G of 1 is undefined. And so because we can't evaluate g, we can't evaluate h minus g. H minus g of 1 is also undefined. What we're seeing here is 1 is not in the domain of g, therefore it can't be in the domain of h minus g. Let's see what happens if we try to take f times g of 9. That'll be f of 9 multiplied by g of 9. Well, to take f of 9, we look in f. We see that input 9 gives output -3. Then to take g of 9, we look in g and see input 9 gives output 0. We'll take -3 times 0. We can do that. That just works out to 0. No problem there. If we want to take g over h of -8, that'll be g of -8 over h of -8. To take g of -8, we look in the function g. We see input -8 goes to output -6. To take h of -8, we look in the function h, and we see input -8 goes to output 3. So g over h of -8, that's -6 over +3. That just works out to -2. Finally, f over h of 3. That's going to be f of 3 over h of 3. To find f of 3, I think we've done this before, right? Input 3 goes to output 0 in function f. To find h of 3, in function h, input 3 goes to output -3. Well, that's 0 divided by -3. 0 in the numerator is just fine. 0 divided by -3 is just 0. So the only place that we saw something that was not in the domain of the combined function was when we tried to take h minus g of 1. G of 1 was undefined, so h minus g of 1 was undefined. We can talk about the domains of these combined functions more generally. Here we have the same three functions, f, g, and h, given as pairs. And we're going to start by finding the domains of each function. So the domain of f consists of all of the x values appearing in f. So that consists of -8, -6, 3, 4, and 9. The domain of g consists of all of the x values appearing in g. So that's just the set -8, -4, 3, 7, and 9. And finally, the domain of h consists of all the x values appearing in h. So that's just the set consisting of -8, 0, 1, 3, and 9. Okay, so that's the domain of each of the given functions. The domain of f plus g, well, that's the domain of f intersect with the domain of g. So I'm going to go through the domain of f and see what's also in the domain of g. -8 is also in the domain of g, so that's in the intersection. -6 is not in the domain of g, so that's not in the intersection. 3 is also in the domain of g, so that's in the intersection. 4 is not in the domain of g, so that's not in the intersection. 9 is also in the domain of g, so that's in the intersection. So the domain of f plus g, which is the domain of f, intersect with the domain of g, consists of the three numbers -8, 3, and 9. Let's do the same thing for these other examples. Right, so the domain of f minus h, that's going to be the domain of f, intersect with the domain of h. So again, I'm going to go through the domain of f, find everything that's also in the domain of h. So I've got a -8, that's also in the domain of h. -6, that's not in there, so that's not in the intersection. 3, that's also in the domain of h, so that's in the intersection. 4, that's not in the domain of h. 9, that's also in the domain of h. That's also in the intersection. So it happens that those two intersections were the same, -8, 3, and 9. For the domain of g times h, that's going to be the domain of g, intersect with the domain of h. So now I'm going to go through the domain of g and see what's also in the domain of h. -8, also in the domain of h. -4, not in the domain of h. 3, also in the domain of h. 7, not in the domain of h. 9, also in the domain of h. It happened that all three of those were the same. What about the domain of h over g? Right, that's going to be the domain of h, intersect with the domain of g, intersect with the set of x such that g of x is not 0. So let's see what that is. We'll go through the domain of h, And first we'll check whether the number is also in the domain of G, and then we'll check whether G of it is 0. So -8, also in the domain of G. G of -8 is 6, not 0. So G of -8 is 6, which is not 0. So -8 can be in this set. Next, 0 is in the domain of H, not in the domain of G. That's not in the set we're building. 1 is in the domain of H, not in the domain of G. That's out. 3 is in the domain of H. It's in the domain of G, and G of 3 is -7, which is also not 0. So 3 can be in this set. And finally, 9. 9 is in the domain of H. It's also in the domain of G. Oh, but G of 9 is 0. So 9 is not in the domain of this quotient. The domain of the quotient is just the set containing the numbers -8 and 3.